Hello and welcome to this SQL interview problem, practice problem. And it's actually from HackerRank and it's based on Harry Potter. So it's quite interesting. At this current date, it's very relevant. So him and his friends are at Ollivanders with Ron. They need to replace a broken one. That's not too important. So the best way for us to choose this is by determining the minimum number of gold galleons needed to buy each non-evil wand of high power and age. Now this sort of language makes it quite complex to understand, but I think what we need here is a window function to put together some of those concepts, the power, the age and the coins required. So we need to print ID, age, coins needed and the power, and then we need to sort it into descending power. And then we'll need to use an order by to look at sorting of results. Now, we're also going to rely on two tables. So in wands, we have an ID integer, a code integer, coins needed, and power. So that's fine, we can work with that. And in the wands property table, it's going to essentially form a pretty simple join here. We've got the code of the wand again. So that could be our primary and foreign keys. So that's how we're going to link a join. And we've got is evil. So this is, it's integer here, it could be a bit data type and it denotes whether the wand is good for the dark arts. So essentially we don't want an evil wand. So you would want to restrict that or filter it where that is evil has a value of 0, which is commonly used to denote false. So that's fine. And in the final explanation, it's not that relevant when we get down to this stage, but yeah, we're going to want those 4 relevant columns. And that should be fine to get going and to understand this problem. And it is available on HackerRank within the Harry Potter and Wands problem, or it may be called Ollivander's Inventory. Now, I just wanted to highlight a few things here. Where it says the minimum number of gold galleons needed to buy each non-evil wand of high power and age, it's not very well phrased because what it's actually looking for here is the cheapest wand for a combination of age and power. So in order to get this, we'll likely use a window function, potentially a row number. You could also use dense rank. And then we're going to write a query to print the ID, age, coins needed and power. So we're also going to have to join the two tables together and we're going to need to filter by those that not evil wand, and then we're going to have to look at that the row number that relates to that cheapest coin for the power and age combination. So we'll likely use a subquery or derived table. You could use a CTE. You could use a temp table. There's lots of different approaches, but yeah, let's look at how we can solve this. So naturally, we can begin the query just by specifying what we're actually going to select as part of our outer query. So as part of our inner query in the from clause, we will use a derived table. You may know it as a subquery, where the main difference would be a subquery would likely be used in the where clause, and we're using this within the from clause. But yeah, so there's not a huge difference there, and we're going to select the ID field from wands, and we need the age from wands property, we're going to need the coins needed from wands, and lastly wands power. So we actually only require the one field from wands property, but we're going to need that to link together the code so that we can actually join the tables. So as you can see here, we need to figure out the best way to get those the coins required for that combination of high power and age. So I'm just going to generate a new field here that will be used in our query. I'll alias it using the equals operator as I'm using SQL Server. So I can use row number because essentially I'm going to want to partition this by the power and age, and I'm going to want to get a corresponding ranking so that later on I can filter this to show the cheapest option in ascending order, and I can use an integer to get those correct results within our query. And as you can see, we'll just order this by the coins needed, and naturally that will order in ascending, so lowest to highest. So now we can close off that window function, and we need to specify a from clause. So this is going to come from ones, from that standard ones table, one of the two that we were presented with for the challenge. And we'll need to join this just with a standard inner join for those matching records using the code. So we will join the table ones underscore property, the second table that we were presented with, on that code fields from the respective tables. I won't use shorthand aliases, I'll use proper aliases just to make this as readable as possible. I'd encourage you to do the same if you have the time or resources. Now, if you remember, we also needed to restrict this by non-evil ones so we can check. And as we can see here, the value of is evil needs to be 0, essentially to reflect that it's false and it's a good wand, it's used for good. So you could, I'm just going to put in the where clause for readability, where one's property dot is underscore evil is equal to 0, and that will successfully restrict our inner query. Now, it's worth noting that you could use syntactic sugar, and you can actually add and. You could say and one's property dot is underscore evil is equal to 0 within your inner join. But I'm just going to use where just for a bit of readability. And then I'm just going to alias my derived table. I'll just call it subquery, make it nice and simple to reference should you need to. So then we can just say, we created that window function, we can say where coin ranking is 1, essentially, where it's that first cost within the combination of that power and age. And we can finally order this by the top power descending and the age descending. Also, because it said if more than one wand has some same power, sort the result in order of descending age. So we can see if this runs successfully, and it has. But it was just an example to show that this may seem simple on the face of it, but there's quite a lot to unpack. As usual, if you enjoy this, like, comment, subscribe, and share. Thank you.